2 that we didn't quite get to on Monday. Hope you're having a good week. I just wanted to remind everybody that on Monday we talked about angle relationships. So in 3.1, we talked about 4 main angle relationships. And basically 3.2 now gives us a postulate and 3 theorems that deal with that. So let me explain what that means. So in 3.1, we talked about corresponding angles. So corresponding angles, I can see here in the top picture, corresponding angles are angles that when you have 2 parallel lines and they've been cut by a transversal line, which is T, then the angles that correspond to each other, so 2 and 6 correspond to each other, they are congruent. So that's this word here. And this is a postulate for the corresponding angles. So postulate means that it's a rule that is generally accepted that we don't prove. Okay, so we spent time on Monday talking about this postulate and how it can help us solve for angles. We're going to talk today about 3 theorems that go along with other types of angles that we have. And let me switch over to Paint here. So you're going to want to write these down on your postulate and theorem sheet that you get to use for the test. We'll call it your reference guide, right? So these are the 3 theorems. So when we have corresponding angles, remember corresponding angles are the ones that are matched up. So, oops. Let me get my brush here working. So in this picture, a corresponding angle would be here and here, or here, oops, wrong picture, here and down here. But what we're going to talk about is, and that idea of corresponding angles being equal, being congruent, is dealt with by the postulate. The other 3 types of angles that we talked about that were formed by transversals of parallel lines, those properties are taken care of with theorems versus a postulate. So if you're kind of like, what's going on with all this? There was 4 types of angle relationships we described in 3.1. In 3.2, one of those gets defined by a postulate and the other 3 get defined by theorems. Okay, so enough about that. So what the second type of angle relationship we talked about were alternate interior angles. So we kind of broke that down, right? Alternate means opposite and interior means inside. So 4 and 5 here are opposite interior angles. And so if 2 parallel lines are cut by a transversal, that's what we talk about, then we have alternate angles, and those alternate angles are congruent. So let me, okay. So that's the first one that you want to put into your cheat sheet notes. You also may want to draw a little picture of what that looks like, because I think it's helpful to kind of see versus the words. Okay, so that's theorem 3.1. Theorem 3.2 deals with alternate exterior angles. So again, we have alternate, that means opposite sides. And instead of interior, inside the parallel lines, these are exterior. Well, guess what? If you have 2 parallel lines, they're cut by a transversal, then the pairs of alternate exterior angles are congruent. So we have postulate that tells us corresponding angles are congruent. We have theorem 3.1 that tells me alternate interior angles are congruent. And we have theorem 3.2 that tells me alternate exterior angles are also congruent. Okay. And then we have, lastly, we have theorem 3.3, which is our consecutive interior angles. So interior, again, is inside, but instead of being alternate, they're consecutive. So it would be nice if the answer to this was congruent also, but it's not, because if you think about it, how can the alternate angles be congruent and the consecutive angles be congruent? That would be a little bit tricky to do. So we have, if 2 parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, and do you remember what supplementary is? So supplementary just means adds up to 180 degrees. So angle 3 and angle 5 are supplementary, and that means that they add up to 180 degrees. Complementary is 90, supplementary is 180. Okay, so let's use a couple of these theorems, put them to work with the last few examples in 3.2. So let me pull that up here. All right, so we are going to put some of these theorems to good use, okay? So first we have use the properties of parallel lines to find the value of x. Okay, so R and S are our parallel lines. They're cut by a transversal line here. So we have 113 degrees describes this angle, and we have 3x minus 4 describes this angle. So first we need to figure out how are these two angles related? So these are definitely alternate, right? They're not on the same side. So they're definitely alternate angles, and they're outside of our parallel lines. So I would define these as alternate exterior angles. So if I want to use any of my information I just found out, I'm going to use theorem 3.2, alternate exterior angles. And what that says is if there's two parallel lines, they're cut by a transversal, and we have alternate exterior angles, then they're congruent. So that means that if they're congruent, they're equal to each other. So that was a lot of words to say that excuse me, I always like to forget to write brushes, that my two alternate exterior angles are congruent to each other, which means that they're equal to each other. And 13 equals 3x minus 4. Okay, so I can solve for x, right? I need to add 4 to both sides. I get 117 equals 3x, and that means x equals 39. All right, so that's how we're going to use the theorems. I think the theorems are pretty easy to use. We just have to figure out which one we're using. And so if they asked the reason why, you would say that that's thanks to theorem 3.2, right? That's our alternate exterior angles. Okay, so example number 3 says, a taxiway is being constructed that intersects two parallel runways. So you see my runways, and it's been intersected. You know that the measure of angle 2 is 98 degrees. Okay, what is the measure of angle 1? How do you know? Okay, so what are angle 1 and angle 2? So that's the most important thing, to figure out what types of angles those are. And angle 1 and angle 2 are opposite each other, so we would say they're alternate, right? And they are also inside of my parallel lines. So these are alternate interior angles. So that means I am going to use theorem 3.1 to help me solve this, because that theorem 3.1 is the one that deals with alternate interior angles. And what 3.1 tells me is that alternate interior angles are congruent. So it's basically saying that angle 1 is congruent to angle 2. Okay, but they're giving me measures. So if I was using this as a proof, they're giving me that the measure of angle 2 is 98 degrees. So we can also say, because angle 1 is congruent to angle 2, we can say that the measure of angle 1 equals the measure of angle 2. And that's the definition of congruency. Okay, so make sure you can always back up what you're thinking, right? So measure of angle 1 equals measure of angle 2. We know the measure of angle 2 equals 98 degrees. So therefore, the measure of angle 1 is also 98 degrees. Okay. Last up, we have find the value of x for problem number 2 down here at the bottom. So let's switch up our colors here. So now I need to look at my angles. I have two angles that are labeled. I have 3x minus 7 and I have x plus 5. So how are those two angles related? So you've got this angle here and this angle here. Well, they're alternate to each other, but one's interior and one's exterior. So I can't use any of my theorems the way they're written, but I can probably use some other information that I know to figure this out. Let me take this off so we can see. Okay, so what do I know? Let me actually, that's a little too big. Okay, so since I can't use any of my theorems or my postulate the way that these are written now, what I can do is I can use some other information that I have to solve this problem. Okay, so one piece of information that I have is that I could say that x plus 5, this angle right here, is a corresponding angle to this angle right here. So here's my two parallel lines. It's being cut by a transversal. So that means that these two are my corresponding angles, which means I can use postulate 15. And postulate 15 says corresponding angles are equal. So I could say that this is x plus 15 due to postulate 15. P15 helps me out for that one, right? And then we know that since this line is being cut by a transversal, right, the measure of a line is 180 degrees. So I could say 3x minus 7 plus x plus 5 equals 180 degrees. And then I can go on to solve that. So that's one possible way that I can get an equation. If I go to solve that, I'm going to get 4x minus 2 equals 180. And you're going to end up with x equals 45.5. So that's one possible way that I could solve this using information that I already know. I'm going to pull this off of here. Take a little bit to erase it. Another theorem or postulate that I could use is, wait just a second to erase. All right. That's as far as it'll let me go back. Another possible piece of information I could use is I could use my knowledge about vertical angles. Okay, so vertical angles, remember, are the ones that are formed when two lines cross each other and they're equal to each other. So by the definition of vertical angle, I can also say that this angle down here is 3x minus 7 because it's a vertical angle across here. Okay, now I have these two angles, and these are consecutive interior angles. So 3x minus 7, this angle down here, it's hard to see, and x plus 5 are consecutive interior angles. So if I use vertical angles first, and then I say, okay, well, they're consecutive interior angles, so that means that they're supplementary. So that would mean that 3x minus 7 plus x plus 5, they're supplementary, so that means they equal 180 degrees. And that's the same equation that we had last time. Okay, so I hope that made sense to you guys. 3.1 and 3.2 are really related to each other. So once you get the terminology down in 3.1 and then learn the theorems and postulates in 3.2, it should be pretty easy to do. So if you have any questions, please join with me on Friday morning and I'll be happy to go over any of those. Have a good day. Thanks. Bye.